So is that one? Yep. Shut the doors? Yeah. Shut the back door. Yeah. Shut this one.
Do you accidentally did it all straight up? Or?
Is this working?
On?
Yeah, do I need to turn it up?
Yep. Should be working.
Okay, is that working? Yes. Right, I might bring proceedings to a start. When I put it quiet. Welcome everyone to this session on climate change projections and impacts. My name is Darren Ray. I'm going to be chairing this session. So this session on looking at the projections of change for the next few decades and beyond, and the impacts that those projections of change might mean or even be already observed for natural systems and the communities and industries that depend on them. We've got 6 presenters, I believe. There will be 15 minutes for each presentation. We'll have time for questions, hopefully in between each presentation, so try and keep your questions until the end of each presenter. There's also a session this afternoon in this theatre at 3:20 on climate change adaptation planning, so I imagine that many of you that are interested in this session might want to come along to that one as well. I'll be keeping time through things, so you'll see me pop up and bother the presenters occasionally towards the end of their presentation. But with that, we're pushed for time, so I'll hand straight over to our first presenter, who is Darren Ray from the Bureau of Meteorology.
Thanks, Graham. So the last 12 months has seen some significant variability in terms of a near record strength El Nino event that's impacted Australia. So we've had very hot and dry conditions across fair part of Australia in the last 12 months or so. And so El Nino is a pattern of year-to-year variability where we see movement between the neutral phase in the Pacific Ocean, the El Nino influence, where we see warm water move away from Australia, we end up with cooler water around northern Australia. We see changes in atmospheric circulation over the top of Australia. Is one of the key mechanisms in terms of the impacts of El Nino in terms of the atmosphere tends to sink down, so we see increasing air pressure over the top of Australia in El Nino events. The opposite phase, La Nina, we see stronger trade winds, warmer water out in the Western Pacific, and we see decreased air pressure over Australia. So that sort of year-to-year variability, we see these events happening on average about every 4 to 7 years if you look across the whole climate record. But there is significant decadal variability in this sort of process of natural variability that has significant impacts on Australia. So that's often not well appreciated. So I'm going to talk a bit about that today and how that might link in with climate change. So in terms of variability in the Pacific Ocean across the multi-decadal time frame, so 20 to 30 year time frame, you see, looking back through the record, movement between different phases of background conditions in the Pacific Ocean. So in one phase, there's a couple of different names for this. There's a pattern called the Pacific Decadal Oscillation that was identified in the northern Pacific Ocean. So we see variations in the between what's happening over in North America and over near China and Japan. There was a pattern identified called the Interdecadal Pacific Oscillation, which is essentially a Pacific basin-wide, so northern and southern hemisphere or north and south Pacific basin analysis of this temperature variability. And just very recently, there's been some work that's just come out in the last year or so. Both of these patterns, this pattern of variabilities, have been identified through statistical analysis, basic principal component analysis of the ocean temperature patterns. That's a fairly complicated process to do, and it's not very good for real-time monitoring. So there's some recent work identifying ways of running this, identifying this pattern of variability using the difference from average of ocean temperatures across different parts of the basin. So a more simplified way of doing that, and that's called the tripole index. So you may start to see that coming out in the literature a bit more in terms of this variability. But so all three of these indexes actually match, all three of these calculations of the pattern of variability look very close to each other. So there's a graph on the top there. It's got the PDO in the red, IPO in the blue, and then below that, on the bottom, there's a graph of TPI showing there's very similar. They correlate very closely to each other. So while the PDO is not exactly the same as the interdecadal Pacific oscillation across the northern and southern Pacific basins, it does match pretty closely to each other. So I guess the key point with this is there's different phases. In the negative phase, you see a more La Nina-like background condition in the Pacific Ocean. So you see cooler ocean temperatures through the central and eastern Pacific basin, and warmer water in the western parts of the Pacific basin, in both the northern and southern parts of the basin. In the negative phase. In the positive phase, you see background conditions which are more El Nino-like. So you see more warmer water in the central and eastern Pacific basin, a bit like what we've observed over the last 12 months, but extending over a multi-decadal period, so 20 to 30 year time frame, and generally cooler water in the western Pacific. So you also see a difference in the frequency of El Nino and La Nina events during those different phases. So in the positive phase, it's got a more background El Nino state. You tend to see a significantly increased proportion of El Nino events to La Nina events, and the frequency of an La Nina event happening after an El Nino event actually decreases. So there's a lower chance of that movement from an El Nino into a La Nina event. In the negative phase, where it's a bit more La Nina-like as background, you see twice as many La Ninas compared to El Ninos, roughly, and there's an increased likelihood that if you have an El Nino, it will be followed by a wetter, cooler La Nina event about 2/3 of the time. So that's significant in terms of if you have an El Nino event with hotter and dry conditions, there's a good chance that will be relieved in the negative phase by a La Nina event following that. So that has significant consequences on things like water availability and so it also impacts weather patterns. So you tend to see in the negative phase, which is the image on there, you see stronger trade winds. You tend to see decreased surface pressure. So it does impact the background weather patterns. So there's a connection between these variations over 20, 30 year time frames and background weather patterns in terms of impacts on sea level pressure, wind patterns. And we see that. I'll show some evidence of that in some of the observations. So in terms of the impacts on rainfall, that's a pretty typical pattern. So we saw a positive phase through the 20s to the 40s, and very quite dry conditions across most of Australia, particularly the central and eastern parts. And in the negative phase, that's through the 1940s to the late 70s, where we saw quite a significant number of La Nina events, particularly through the mid-70s, and quite a bit wetter conditions across the eastern parts of Australia. So it has significant impacts on, for example, the Murray River system in those different phases. So looking at Murray River rainfall anomalies across the Murray-Darling Basin that feed into stream flows, you can see the blue bars are La Nina events, and the brown and orangey bars are El Nino events. And you can see an increased frequency of La Nina events in the negative phase, an increased tendency towards stronger positive rainfall anomalies, and tendency towards more El Ninos and dry conditions in the negative phase. There's also other impacts that have been identified through research in terms of impacts on crop yields and temperatures, river flows in different phases as well. Now, in terms of climate change impacts, there's been significant impacts on rainfall across southern Australia in the April to October period. So that's a trend map of April to October rainfall over the last few decades, showing significant drying, particularly in southwestern WA, but also in our locality and across into southeastern Australia in the April to October period. So research is identifying that as being a response to changes in the weather patterns. Warming at the surface means the Hadley cell increases in height, and also in response to that increases in width. So that Hadley circulation cell essentially means in simple language, the tropics are expanding in response to the warming of the planet. And that's being observed in the northern southern hemispheres about 0.5 to 1 degree of latitude per decade. So about 50 to 100 k's per decade, the tropics are expanding south. So we're seeing a climate change impact on weather patterns, and that's reflected in surface observations. We're seeing stronger high pressure systems along southern coasts in response to that. So climate change in Australia has identified that in their work. So that's the latest body of work in climate change projections, and that highlights over this region that the surface pressure has been increasing and is projected to further increase over coming decades in response to climate change, depending on the emission scenario. So we've got a low emission scenario on the bottom there, medium and a high on the top, and particularly over winter, there's very indications of continued strengthening of weather patterns in response to climate change. And we can see that reflecting in rainfall declines across this part of the world. So once again, depending on the strength of the decline, depends on the scenario. So we've got declines of say 5% or so in low emissions, maybe around 10% in the medium emissions, and getting up to sort of 15% or 20% in the high emission scenario. So we're seeing significant impacts, starting to see significant impacts from climate change. And it's interesting looking at ROBE, April to October mean sea level pressure. So I focused on April to October as a key time of year in terms of rainfall for cropping farmers, but also in terms of time period that we collect most of our we see most of our rainfall being collected and rainfall generating runoff into catchments and dams and river systems. So it's interesting to see the variability through there. So there is variability prior to that sort of 1990 or so period over the multi-decadal time frame, and that's reflecting the influence of that multi-decadal variability through the IPO on weather patterns over Australia. So we see that reflected variations of a hectopascal or two over different decadal periods. So there's there are periods, so there's periods in there that match up. There's a negative correlation, stronger high pressure systems through positive phases, and lower surface pressures through negative phases. But the last few decades or so has been a really clear trend upwards with increasing surface pressure being reflected. And so in what has been a negative phase of the IPO. So what should have happened through natural variability is actually the surface pressure should have been decreasing over the period from about the mid-late 90s through to about 2013. But instead they've gone up quite significantly in response to the climate change influence. If we look at correlations between rainfall across the upper southeast, for instance, and the mean sea level pressure, there's very strong correlations there. And we're seeing that sort of variability in rainfall on a multi-decadal basis, but then very strong declines in the last 20 years or so in response to that increasing surface pressure from the climate change influence. And the similar sort of pattern in the Mount Lofty Ranges. It's a very strong correlation between the surface pressure patterns, multi-decadal variability, and then a climate change trend on the end of that. Now what's really concerning, we've been in the negative phase, so in one sense we've actually had the multi-decadal variability acting against the climate change influence, but that's actually, we're seeing indications we could be starting to move into the positive phase. So since about early 2014, the PDO or IPO values have gone quite strongly positive, and that's concerning because for the first time we could be seeing the combination of climate change influence and this multi-decadal variability acting together in terms of producing a drier influence, stronger high pressure systems that are drying over southern and eastern Australia. Some of the wrinkles in that, the oceans are warming up pretty strongly as a background. So while we see variations over multi-decadal periods in the patterns in the oceans, there's a general background warming from climate change, and that supplies more moisture into the atmosphere. And so we're seeing situations where that's starting to counteract some of the drying that you might expect from nuclear variability. So for instance, in 2015, in this very strong El Nino event, we actually saw wetter conditions across the central parts and western parts of South Australia, and close to average rainfall across the Murray-Darling Basin in what was a very strong El Nino event. So some complications in there. In terms of longer term indications, looking at some paleoclimate records, this paleoclimate reconstruction is actually the negative of the IPO. So positive values are actually wetter periods, and then so it's highlighting that period through the 50s and 70s, 1950s to 70s, was actually fairly unusual. It was matched by one other period back in the 1700s. So a lot of our water use has grown in response to that, what was a significantly wet period, as indicated by these paleoclimate indicators. But also that the quite dry conditions through the 1930s and 40s there is a period in there right at the start of the paleo record indicates that we potentially could see conditions through natural variability, this multi-decadal variability, being significantly worse than what we have experienced through the 20th century. So yeah, the other thing to keep in mind is that sort of variability in the Indian Ocean. So the Indian Ocean is quite important, as I sort of touched on, as a moisture source for South Australia. It can act against the El Nino La Nina influence or the IPO influence to some degree. So yeah, just to summarise quickly, we do see multi-decadal variability and influences as expressed in the PDO and IPO and those newer tripole index. So we see more of a La Nina type background in the negative phase, more of an El Nino type background in the positive phase. We're seeing some climate change impacts. We haven't really seen a combination of positive IPO and climate change signals happening before, but there's some indications we could be starting to move into that since about early 2014. So it's something that could have significant impacts on stream flows, rainfall stream flows over coming decades. So something to keep in mind in terms of our planning. Thanks.
Thanks very much to Darren. We're pushed for time a bit already. Can I ask that any questions, can we just hold them until a bit later? You can ask questions on Darren's presentation later. Move on to the next presenter, who is Louise Wilson from the CSIRO. Louise is going to present on regional scale climate change projections for Australia and South Australia.
Yes. Well.
And you need to turn on.
Yeah.
Okay.
Sorry.
So we kind of have to upload the